All right, in keeping with the theme that I was just talking about, which is that what we learned on Friday is really what we learned on Thursday. In keeping with that theme, what we're going to be learning today is really what we learned on Friday, which is what we learned on Thursday. There's just a little twist to it. Okay, it's a minor thing. It's an important thing, but it's pretty simple. We're going to be looking today at dividing rational expressions. So what I'm telling you, let's back up. You know how to simplify a rational expression, factor and cancel. You know how to multiply rational expressions because really when you multiply rational expressions, you get a single rational expression, which is what we learned Thursday. What I'm telling you right now is that when you divide rational expressions, we're going to turn them into multiplication of rational expressions, which is what we learned Friday, which is really what we learned Thursday. Are you with me on that? Okay. So we're looking at dividing rational expressions. To begin with, you know me, I don't like rules very often, but sometimes they are useful. Okay? When it comes to simplifying things, we are not going to use this rule very often. Okay? I want to make this clear. The only time you're going to use this rule I want to talk about is if I say take this rational expression and divide by this rational expression. Okay? And it says that a fraction being divided by another fraction is the same as taking the original fraction and multiplying by the reciprocal. And I hope that this is something that you remember. But for example, if I have 10/3 divided by 1/2, that's the same as 10 over 3 times 2 over 1, which is 10 times 2 over 3 times 1. So look what's happened here. I've gone from dividing two fractions to multiplying two fractions to a single fraction. I've gone from today's work to Friday's work to Thursday's work. And then you can cancel common factors. There aren't any here. There's no factor in 10 that's common to 3, and 2 is not common to 3. So it would be 20 over 3. So that's the rule that we're going to be using today. You can try this with some numerical fractions. I hope you remember that rule. Okay, but I hope you also remember that when we're doing algebra, I tend to say, let's not do that. Let's do something different. And later on in the unit, when we do more complicated things, I don't want you going back and saying, I thought we're supposed to multiply by the reciprocal. You're only going to multiply by the reciprocal if I give you stuff like this. Simplify. 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 Ugh. Get knocked back on your heels just looking at that one. That's okay though. But we have a question to warm up. In this expression, let me rewrite it. A over B divided by C over D. What are the non-permissible values? So who can tell me one non-permissible value? Jay? B is not allowed to be 0. Excellent. Can somebody different give me a different one? Yeah? C. Okay. I'm going to write that down. That's correct. I'm not going to ask you why just yet. Because when I do ask you why, I'm going to have a condition on what your answer has to be. Okay. Are there any other, by the way, how many of you see that C cannot be 0? Okay. Are there any other non-permissible values? The other one is D. D is not allowed to be 0. So my first question to you is this. Why is B not allowed to be 0, Jay? You said B. Why is B not allowed to be 0? Right, a fraction with a denominator of 0 is not defined. So this thing that I'm going to highlight is not allowed to be 0 because if it is 0, then this fraction is not defined. Okay? By the same reasoning, I hope you can understand that D is not allowed to be 0 because if D were 0, this fraction is not defined. Okay? In other words, both b and d are denominators. And denominators can't be 0. Ashira, without talking about rules or reciprocals, can you tell me why c is not allowed to be 0? Because I suspect that most people would say, well, because when we divide by c over d, we're multiplying by d over c. And is that what you were thinking? And then that c becomes a denominator. But without, and I think this is very important, without talking about reciprocals, why is c not allowed to be 0? Yeah.
Is it because if you took a over b and divided it by c being 0, then it would be like dividing it by 0?
Right. If c is 0, then, and I don't know that you can communicate this all in written form, everybody, but if c is 0, then this fraction is 0, and that's allowed. You're allowed to have that fraction being 0. 0 for c over some other non-zero number is allowed. It's 0. But you're dividing by that whole fraction. So when you divide, you can't divide by 0. b and d are not allowed to be 0 because they're denominators, which means you're dividing each of those little fractions by something that results in division by 0. But c is not allowed to be 0 because it makes that whole fraction 0, and you can't divide by 0, and you're dividing by the whole fraction. So what the rule is going to be, and sometimes rules are good, non-permissible values happen when the denominator of any expression is 0 or the numerator of any expression you're dividing by is 0. So if we take a look up here, please, if I take a look at b, I'm going to highlight the things that are not allowed to be 0. This is not allowed to be 0. This is not allowed to be 0. And this is not allowed to be 0. Because if either of those denominators are 0, each of the fractions are not defined. And if the numerator of the second one is 0, then you'll be dividing by 0. Because the whole fraction will become 0. This is not allowed to be 0. This is not allowed to be 0, neither is that. Any denominator or numerator, let me say that properly, any denominator is not allowed to be 0, period. Any numerator of a fraction you're dividing by is not allowed to be 0. And we could continue this, right? All of these things are not allowed to be 0. They're going to lead us to non-permissible values. Denominator, 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 numerator of a fraction we're dividing by, numerator of a fraction we're dividing by. Same thing. Okay. So, let's put everything I've taught you in the last 5-6 minutes or so into practice. Simplify. Well, what do we do first? I guess let's do our non-permissible values. C is not allowed to be 0 because each of those fractions has c in the denominator as a factor. A is not allowed to be 0, and b is not allowed to be 0 because if either a or b are 0, then this whole thing will be 0, and you will be dividing by 0. Not allowed. Okay? So we've got our non-permissible values out of the way, which we need to do before we cancel or do anything. Let's rewrite the question. As the multiplication of two rational expressions using our reciprocal rule. And now it is a question from Friday. And if you watch very carefully up here, it's currently a question from Friday. Now it's a question from Thursday. Cancel factors on the top and the bottom. we're supposed to factor everything first. Is this already factored? How many of you feel as though this is already factored? How many of you think it's not factored? I could accept yes to either of those. How many of you can look at this and go, well, it's basically factored, because I know that 35 is 7 times 5, and this is A times A, and this is B times B. You don't need to write it out explicitly as factored form, as a factored form, if these are monomials, which they are. Okay. I'm going to write it out that way just because you do not need to. 35 in factored form is this. AABB. I hope you understand, it's not foolishness, that's maybe the wrong word, but I'll use it anyway. The kind of foolishness of writing it out this way. You don't need to. And then I have a 2 and a 5, 2 and a 5 and a C. On the bottom I have a 5 and a C, and a 7 and a 3. And see, this is why I say foolishness. I'm not saying you're being foolish if you do this. I guess maybe a better word is you're not being very economical with your time. You're wasting a lot of time. And then I also have B. I think this is also a case of the more you write, the easier it is to be confused looking at it. I think. I am anyway. There's just so much happening here, right? 7, 7, 5, 5. Do I have a C? I've got a C here and a C here. I've got a B down here and a B here. I've got 2 A's and 2 A's. What do I have left on the top? I have a B and a 2 and a 5. Do I have a B on the bottom? No. Do I have a 5 on the bottom? No. A 2 on the bottom? No. So I have 10B on the top over 3A squared. And by the way, if I did miss some things that could be factored or could be canceled rather, I would notice it here, right? I would see like 6 on the bottom and go, oh, there was another 2. Any questions with A? All right, so we have to rewrite this. Well, you know what? I hope that it's clear, everybody. There are 2 main things that need to happen. You need to factor everything, and you need to turn it into a multiplication. Listen very carefully. Some of you might be tempted to factor everything and flip the division, the divisor, over at the same time. I highly recommend against doing that. It's just easy to make a mistake if you try to do too much at once. So I am going to leave the division here. And maybe what I'm getting at is the thing that ramps this up now to a higher level is you just have to be more organized and thoughtful. There's more going on. And then x squared plus 6x plus 8 is x plus 2, x plus 4. Let's do our non-permissible values. Not equal to -4, -2, or plus or minus 3. Because again, non-permissible values are where any denominator is equal to 0 or where any numerator of what you're dividing by is equal to 0. Because if that thing we're dividing by has a numerator of 0, then that thing we're dividing by is 0, and you can't divide by 0. Now we flip it over. By the way, some of you might be tempted to start canceling up here, anticipating what's going to happen when you flip over. Don't do that. And then we have times, why not just put one fraction, x plus 2, x plus 4, over x plus 3, x minus 3. Could we have flipped it over and then done the non-permissible values? Yes. But just be careful that you are sure what was an original numerator, because usually when you flip it over, you put it together as one thing, right? We're just so close to being done. X minus 3, x minus 3, x plus 4, x plus, we're done. X plus 2 over x plus 3. Can you put your phone away, please? With those non-permissible values. Any questions with that one? Factor, flip, cancel. Let me just show you what would happen if we flipped first. Okay? If we flip first, and this is okay, I think there's a little bit of an issue with it. If you put this together as 1, then make sure that you keep track of all of these pieces as being contributors to the non-permissible values. Because, you know, this piece was the numerator of what we were dividing by, so it can't be 0. I mean, it's okay to flip first. I much prefer to factor, do my non-permissible values, and then flip and cancel. For those of you, and Ashira, you're one of them, because originally I said, why, I think it was C. Why can C not be 0? And you said, because when I flip it, it becomes a denominator. That's okay. There's nothing wrong with that. But I don't want you to think that this, which was a numerator, cannot be equal to 0 because it's a denominator. That's okay. But don't forget that this, which is 3x plus 9, which is a numerator, still can't be 0 because it was originally a denominator. Are you following me on that? Okay, good. So one way or another, you need to know that. We factor everything completely. What do we got here? Difference of squares, 3x plus 2, 3x minus 2. I can factor a 3 out of this, x plus 3, x plus 3. I can factor a 2 out of the 6x minus 4. And without a doubt, I prefer factoring, doing non-permissible values, and then flipping. Because already I'm starting to lose track of what is non-permissible, right? I really have to focus hard to keep track of it. X is not equal to -3. X is not equal to 2/3. And that's it. Yeah, again, I'm almost on the edge of my seat here and wanting to say, I think I should have just not done it this way. I should have just said, look, factor first, do your non-permissible values, then flip. This is a little more, I don't know how to put it. It's harder for me to look at and process. If I would have done that first, I just want you to see this so you can appreciate what my thought is here. I leave it as divided by, and I take that 3 out. Take out a 2. Just to me, it's easier right now to look at these 3 pieces because I still haven't put it together as one fraction yet. Anyway, we can cancel now. What do we got going on here? Boom. Adios. I think that's it, isn't it? I got a 3 in the numerator. I have a 3x plus 2. The order in which you write these doesn't matter, but coefficients or monomials, I should say, are usually written first. That's it. And you don't need brackets around the 3. Can I cancel these 2 2's? Well, no. They're not factors. If I could have, I would have seen them on the left-hand side of the screen in brackets on the top and the bottom. Whew. I hope you can really appreciate now that if we start flipping over stuff right now before we find non-permissible values, it's going to be a bit of a chore. So let's see where we're going. One more after this. These are all, everybody, these are all pretty easy to factor because they either contain common factors like the m squared plus 5m or like the m squared plus 3m, or they're really basic difference of squares like m squared minus 9. And I'll give you a second to catch up in your head with that, with those three so far. They're either really basic common factors or basic differences of squares, or the reason why the other three are really simple is the coefficient of the quadratic term is 1. It doesn't get much simpler than that for factoring. So all of these other three are going to factor into binomials of this form. And we're on the hunt now for numbers with properties. In the top of the first expression, we need numbers that multiply to give negative 4 and add to give negative 3. Well, 4 times 1 is 4, and negative 4 plus 1 is negative 3, so that's pretty easy. The middle expression, well, they have to multiply to give positive 12 and add to give a negative, so they have to both be negative. I guess 4 and 3 will do the trick. That will add to give the 7 in the middle. Well, negative 4 and negative 3. And the 15, one is going to be positive and one will be negative. Two numbers that multiply to give 15, well, 3 and 5. And if one of those is negative and one's positive, they have a difference of 2. That'll do the trick. We're starting to get really close to what I've talked about from the beginning of the year when we talked about factoring. You can't dawdle. Dawdle means take your time with factoring. I mean, you have to take enough time to do it right, but 1, 2, 4, 6, we factored 6 things here. And now we're starting to talk about non-permissible values and canceling. Let's do our NPVs. X can be anything. X can be anything. M, on the other hand, cannot be equal to 0. Let's just take a breath and make sure you understand why M cannot be equal to 0. It's because of that factor of M. We also have negative 5 and 3 and negative 3. What I'm doing is I'm looking at all of the denominators right now. 0, negative 3, 3, negative 5. But now I need to look at the numerators. So I've looked at these. Now I'm looking here. Well, I already have plus or minus 3. I already have the 3. I need 4 as well. So those are the non-permissible values. There's certainly, as much as I say this is just turning it into Friday, which is turning it into Thursday, there's still more work here, right? Now you got to rewrite the whole thing with things flipped over. And I really hope you appreciate, when I said earlier, don't try to cancel and flip over at the same time. Do you see how confusing that would be? Unless I'm alone here. I couldn't handle flipping things over and canceling in one fell swoop. So I have to rewrite things. M minus 4. I'm going to have M plus 1. I'm also going to have M plus 5. M minus 3. M plus 3. I'm flipping over this and changing it to a times. I'm flipping over this and changing it to a times. So this ended up on the top. This ends up on the top. What's going to end up on the bottom? Okay, well, what was on the bottom of the first expression is m and m plus 5. And then I have to write the old top of the second expression, m minus 4, m minus 3 on the bottom. And the same goes for the third, which I'm dividing by m plus 3, m minus 3. And if there was ever a time called for to stop and double check, it's now, right? I mean, there's a lot happening here. But I'm pretty confident that's right. Okay. I have an m and an m. Do I have two m minus 4s? I do. Do I have an m plus 1? Nope. M plus 5? Nope. Oh yeah, I do. Here and here. M minus 3. Can I cancel all the m minus 3s? No. I would need 2 on the top and 2 on the bottom. And then m plus 3. And very carefully, you know, like my dad would say, with a fine-tooth comb, go through this. We have an m plus 1. Just carefully left to right. That's it on the top. On the bottom, wow, there's really not a lot left. Unless my eyes are deceiving me, that's all we have. This is all about factoring, really, and remembering a few other things. One final example. What makes this one more challenging, of course, is give me a second. What makes this more challenging are these things I'm going to highlight. Because then it's not a simple quadratic, it requires a more complicated procedure, trial and error. 2x, 2x, x, x has to be. Well, with the 2x squared minus 5x minus 3, it's got to be a 3 and a 1. I mean, there's no question. If it's going to factor, it has to be 2x and x and 1 and 3. The question is, how can we arrange to get negative 5x? Now, do you remember a second ago I said 1 and 3? Well, if I had said 3 and 1, my brain probably would have written that, and you should be able to multiply that out and see that it's not going to be correct. This is a bit of a tricky one. How many of you feel as though you can get negative 5x out of that? Outer is 2x, inner is 3x. Why can we not get negative 5x out of it, though? You want to give it a crack, Gustav? No? Yeah, I think you almost had it. Jay?
If the 3 is in with the 2, you can't get a large enough number to get negative 5.
That's kind of not what I'm getting at.
2 negatives, like negative 3 and negative 1 would be positive 3.
Right. These two numbers, the 3 and the 1, have to be opposite. One has to be positive, one has to be negative. Maybe that's what you meant, but maybe I didn't quite hear you. So if we switch these, putting a negative here gives us negative 6x on the outer, and I think maybe that's what you were getting at. And a 1 will give us positive 1x, which is negative 5x. Okay, the 15, just follow my logic again. The 15 is going to be a 3 and a 5, most likely. I'm going to try first putting the 3 with the x. Does anybody know why I'm going to try that without foiling it out and seeing if it works or not? Why do I suspect it's probably going to be? In fact, I'll go one step further. I think there's probably going to be an x minus 3, and maybe I'm wrong. What's the reasoning here?
If you put the 5 at the end and multiply it out, that'll already be 10.
Okay, so you're already starting to look at when you do it, it works. But why, without even doing it, do I suspect it might be x minus 3? There's an x minus 3 on the top. Like, you know, things have a way of working out that way. But let's try this and now confirm what Aoki was thinking. Will that give me negative 11x? Yes. Look, I see two x's elsewhere. I suspect these are going to be two x's and 2x. This would have to be 1 and 1. That's actually a pretty easy one to do. We're done. 5 and 1. Negative here gives us negative 8x plus 5, plus 2x is, that gives us negative 8x in total. Negative 10x for my inner, 2x for my outer. Non-permissible values. Are these. Here's a question for you. Can I do this? Why not? That's a single rational expression that's got x minus 3 on x minus 3, and I can do this too. I couldn't do that if they were in opposite or different rational expressions, because I'm still not multiplying. Now I can flip it over. Oh, wow. This is one of these ones where everything goes away. Did I miss something there? Are you with me, or is the heat getting to you? Both. Okay. So what are we left with? 1, right? Not nothing. We're always left with something. Well, unless you take something, subtract the identical thing, then you're left with nothing. But when you divide, you're left with 1. So the answer is 1, but x is not allowed to be those numbers. I want to show something to you now. I'm going to graph this. I am going to graph. It's going to be a bit of a beast for me to enter in, but it will be worth it. 2x squared minus 5x minus 3 divided by, and I'm going to, even though I don't need an extra set of brackets, I'm going to put that entire thing, that entire rational expression in its own set of brackets. And now I'm going to divide by in its own set of brackets. Do you see why I prefer this mode of my calculator and not the one where it types stuff off the screen? Hey, I want to double check this. 2x squared minus 5x minus 3 over 2x squared minus 11x plus 5, 15, over 4x squared minus 8x minus plus 1 over 4x squared minus 4x squared plus 4x plus 1. Oh no, that's okay. Look okay to you? I'm going to go zoom standard. What did we say this was supposed to equal? 1. You see how slow my calculator is moving? It's plugging everything into that mess that I've entered. I'm going to adjust the window settings so that we're not wasting a bunch of space here. Let's go from negative 3 to negative 2 to 3. If I were to go trace and enter 5, it tells me the y coordinate is 1, right? If I were to go trace 2, it tells me the y coordinate is 1. If I were to go trace 3, there's no y coordinate. You know why? Because x is not allowed to be 3. In fact, and this leads to something we're doing right now in Math 30, Don't worry about why this window setting does what it does. Let me pull this off over here. There's what it looks like. I'm going to go zoom decimal. Don't worry about why. How many of you see that? There's little holes in the graph. We actually call them holes. There's a hole at -1/2. There's a hole at 2.5, I think. There's a hole at 3. And the weird thing is, those holes are infinitely small. Like, there's a hole at 3, right? Can I go trace 2.99999? Sure I can. Now, it's telling me y is 1 because that point exists. I can get as close to 3 as I want. I just can't be at 3. So there's little holes there. Factor, non-permissible values, which are numerators of what you're dividing by and denominators of anything. Flip and cancel. So if anything, this is a real workout for factoring and your factoring skills. So get to work on that, please. Yeah.